We're doing some log review problems here. So here's the first one. We have log base 3 of 1/9 equals y. And so we want to figure out what y is. Now remember, this is in the form log base b of an argument equals an exponent, right? So I have this in this form right now. That means 3 is my base, and 1/9 is my argument, and y is my exponent, right? So can I just change this around into exponential form and solve it? So that means 3 to the exponent equals the argument, remember? And what is my argument? That's 1/9. So 3 to the what equals 1/9? Well, y has to be -2, because to get a fraction out, I have to have a negative exponent. Okay, so I know this is going to be a negative exponent, and so it's going to be 1 over 3 to the something. And what does that something have to be? Well, that has to be 3 squared to get to 9, right? So 3 to the -2 would be 1 over 3 squared. So y in this case is -2. So this is in the exact same form. Log base b of an argument equals the exponent. Let's just switch it around. So we have 9 to the -1/2 equals y. So now all we have to do is calculate 9 to the -1/2. Well, remember that's the same as 1 over 9 to the 1/2, because we change the line, cross the line, change the sign. So if you have a negative exponent, you just take it from the numerator into the denominator. Okay, and then what does 9 to the 1/2 mean? It actually means the square root of 9, right? So this is the same as y equals 1 over the square root of 9. And what is the square root of 9? Well, it's plus or minus 3. Okay, so I have plus or minus 1/3, right? Because I just took the square root of 9, so this is plus or minus 1/3. But here's what I want you to think about. Can this be -1/3? Can -1/3 go in here? Well, no, because I cannot put a negative into a log, right? Because logs can only take in positive values. So the -1/3 is not an answer. I can only have the positive 1/3. So y equals 1/3. So this one's in the same form, 25 to the 5/3. This should say 25 equals y. Okay, so there should be a y there. Log base 25 of 5/3. Okay, here we are. Let's switch it around. So we have a base of 25. We have an exponent of y, and we have an argument of 5/3. So 25 to the y equals 5 to the 3rd. Okay, so 25 to the 3rd is 125. But you know what? Let's not do that. Let's not switch that into there, because these actually almost have common bases, right? Right now, 25 and 5, it's really easy to give them a common base. So let's do that. Let's say instead of writing this 25 as 25, let's write this as 5 squared to the y equals 5 cubed. So this is the same as 5 to the 2y equals 5 cubed. And now, since they have a common base, we can just set their exponents equal, right? We can just say 2y equals 3. We divide both sides by 2, and we get that y equals 3/2. In other words, the exponent that I need on 25 to get to 125 is 3/2, because that's what the log asks. It says, what exponent do I need on my base to get to the argument? So the exponent I would need to put on 25 to get to 125 would be 3/2, which makes sense because it's 25 cubed and then the square root of that. So anyway, it works. So our next one here is expanding logarithms. So the first thing I see is a quotient. I see that this is something divided by something, so we're going to split that. So I have log of root x cubed root of y squared minus log of z, because I use the quotient rule to split. You know, I subtract the top, the log of the top minus the log of the bottom. Okay. So then I can use the product rule, because I see that I have a product right here. So let's split that one as well. So this equals log of square root of x plus log of cube root of y squared minus log of z, because I just split up this one right here. Okay. Now The last thing that I see is I see some exponents, and they might not be super apparent to you, but remember square roots and cube roots are just exponents. So let's rewrite this as log of x to the 1/2 plus log of y to the 2/3 minus log of z. So we just rewrite these as exponents. And now that we've rewritten them as exponents, we can take them and bring them out in front, right? So our final answer is going to be 1/2 log of x plus 2/3 log of y minus log of z. Whoop. Okay, next one. Going to expand this one as well, right? So we're going to get it all the way so that it's just like log x, log y, and log z are like all by themselves, basically. So the first thing that I notice is that this square root is over the entire thing. So let me just rewrite this as log of xy squared over z to the 8 all to the 1/2. And the reason I want to do that is because I notice that this square root is applying to every single one. So this is really like the square root of x, square root of y squared, and the square root of z to the 8. And it's easier to do it this way than to just write each square root individually, but if you wanted to write them as each square root, that's fine. So then we can apply, remember the exponent rules tell us, we can apply this 1/2 to each thing inside of here. The other option is we could bring it on front, but you'll see that that's actually an extra step we wouldn't need to do. Let's just apply it to each of these. Remember, because this exponent applies to the x, it applies to the y, and it applies to the z. So we have log of x to the 1/2, y to the 2/2, because remember I multiply them together, over z to the 8/2. Make that a little skinnier for you guys, okay? And so then let's simplify that. So that's log of x to the 1/2 stays the same, but then y is just y, right? And then this is z to the 4th, because 8 divided by 2 is 4. Okay, so now I'm back to something like we looked at before. So it's a quotient, right? So this is log of x to the 1/2 y minus log of z to the 4th. So I can just split them. Now I'm going to split the first one as well. So this is log of x to the 1/2 plus log of y minus log of z to the 4th. So I just split the product. And now we can take down any exponents that we have. So we have 1/2 log of x plus log of y minus 4 log of z. So this is our final answer. And again, if we had taken that 1/2 down first, we would have ended up here as well. It just would have been an extra multiplication step. Okay, we're going to expand this one. This one should be pretty obvious. So we have product. So this is log of x, y plus log of z, right? We can split the first one. Honestly, you could split all three of them at once, but it might be easier to see it this way. So we split off the z, right? And then we're going to split off the x as well. So this is log of y plus log of z. So they're all just adding together since they were a product. Okay, we're going to rewrite this one in exponential form. So this is a base, this is an argument and an exponent. So we start with our base to the exponent equals our argument. And is that true? Is 1/2 to the 3rd 8? Yeah, absolutely, because it's 1 cubed over 2 cubed, which is 1 over 8. If you want to rewrite this in log form, you're like, but it's not an exponential form. Okay, so let's make it an exponential form. Let's remember that the radical is really just an exponent, so this is really just x to the 1/2 equals y. And now we are in that form, base to an exponent equals an argument. So let's rewrite this in log form. So we have log base x, because that's what our base is. What's our argument? Of y equals our exponent, 1/2. So that's that. And remember, the answer to a log is an exponent. Is the answer to this log the exponent? Yes, it is. So we know it's in the right form. Oh, is that all for that page? Yep, okay. So we're going to solve for x here. We notice that we have two separate logs, but they have the same base, which means we can combine them together using the product rule. So we're going to have log base 2 of x minus 2 times x plus 1 equals 2. So I just combine them together using the product rule. And I'm going to go ahead and multiply that out so that I have x squared, let's see, that's minus x minus 2 equals 2. And now I have it in the form log of a base b of an argument equals my exponent, so I can rearrange this, right? I can rearrange this. So I have a base of 2, I have an exponent of 2, and I have an argument of x squared minus x minus 2. Now this is something we've been solving for like years, right? This is really 2 squared is 4. So really this is x squared minus x minus 2 equals 4, and it's a quadratic. So to solve quadratics, we set them equal to 0, so we subtract 4 from both sides. We have 0 equals x squared minus x minus 6, and then we have to factor, or use the quadratic formula. Sometimes the quadratic formula is faster, but in this case factoring would be faster because this factors to x minus, not x minus 6, x minus 3 times x plus 2 equals 0. So that's just factored. So what are my two options? This means x equals 3 or x equals negative 2, right? Those are my two different numbers that would make this whole thing true. But remember, we did a ton of algebraic manipulation to get there. So we need to check to make sure that these work out. So what we're going to do is we're going to take 3 and we're going to plug it in here for x. And we're going to see if that comes out a negative argument, then it's not an answer. Because logs can't have a negative argument. If they come out with a positive argument, then it's going to be an answer. Okay? So 3 minus 2 is 1, and 3 plus 1 is 4. So those both come out positive. So that means that 3 is an answer. Now let's check negative 2. Negative 2, negative 2. Well, I'm going to get a negative argument both places, right? This is going to be negative 4, and this is going to be negative 1. So that means that x equals negative 2 is what we call extraneous, or in other words, it's just not an answer. It's an answer that came up because we did all this algebraic manipulation, but in reality, it's not an answer. So what is the only number that makes this true? 3. X equals 3 is the only number that makes this true.